The topic for my pitch tonight is the water treatment process from source to supply. So as civil engineers, we design, build, and sometimes operate water treatment works. Everyone knows the importance of water. It's vital for life. The World Health Organization estimate that 2.1 billion people worldwide lack access to safe water, of which 263 million people have to travel more than 30 minutes in any journey to collect water. And of that, 159 million people are drinking directly from disease-filled water sources. So from the ground, water treatment works aren't that exciting. They're just a series of consecutive tanks, but you can't really see what's going on below the surface. So we're going to take a look at just each of the processes. So your water is piped in from the source, whether it's a lake, a river, and maybe an aquifer, then passes through a screen. So the screen will stop a lot of debris, leave sticks, weed, fish passing into your treatment works. The flow then transfers onto a coagulation tank where it's dosed with a metal coagulant. So this metal coagulant is positively charged, and it helps neutralize the negatively charged particles, organic matter that's in the water. So if you imagine they're all negative and they're repelling each other, so this coagulant helps bring them together. There's also a chemical called poly is added to the water, and it helps these clumps to flocculate, to create a flock. Over time then these particles will come together, they'll become denser, they'll be heavy, they'll start to settle under gravity, and they can be piped away as a sludge at the bottom of the tank. So this is now for my Blue Peter moment. Here's one I made earlier. The water passes on to a filter. So I'll just show you here from a dirty water source going through. It passes down through a level of anthracite. This is a large sort of coarse-grained material, down through a fine sand, and eventually will make it out at the bottom of the filter. So any particles that weren't captured in the previous processes should be captured in the fine sand. After this, the water is disinfected with chlorine, something similar to like your local swimming pool. And this helps kill any bacteria, viruses. It then sometimes will be dosed with a soda ash. This brings the pH of the water up to 7, which is suitable for drinking. Then the water is either piped to a reservoir where it's stored, where I think Stephanie mentioned the reservoirs. The water goes there for storage, or alternatively, it can be piped straight to the network. And on average, Northern Ireland water supply around 560 million litres of good quality drinking water every single day. So it's something that I think we all take for granted, but it's important to appreciate just the process that's come before, when you're drinking your tap water or you go for your shower or whatever. So this should be starting to filter down through here. It worked last night. Let me give it a squeeze here. Very, very slight amount of water coming through there. But basically the fine sand captures the coarser organic matter or any particles that are still remaining in the supply. So that's it. Thank you.
Shaun Reynolds, ladies and gentlemen. The final time is 230 seconds.
Shaun, excellent, and I think your little prop is working here.
Just about.
We'll check it later just to see how clear it is. Okay, you gave us some very interesting facts there. One of them around aluminium sulfate to help coagulate.
Yes.
Okay. So are there any challenges to using aluminium sulfate in terms of maybe public health?
A massive part of a successful water treatment works is optimizing the process, so you're actually getting the perfect amount of chemical. So that can be simulated on a benchtop jar test. So it basically is a sequence of small jars that what you would have seen in your chemistry GCSE class. and they will take the raw water and they'll treat it with different concentrations, different doses of this coagulant to find what is the optimum amount. There will be alarms and different triggers, and you'll know normally if you overdose or underdose your coagulant, you'll know at the next stage that whether it was right or not, based on how the following water and the following processes respond. But it's a metal coagulant, so obviously, yes, if in excessive amounts, it would be detrimental to health.
You're actually testing that presumably to make sure there's no trace amounts or negligible amounts left.
Yeah, well, every treatment works should have jar tests completed by the operators on a regular basis to ensure that these things don't happen and they overdose.
Can I steal one last question of you?
Yeah.
Why do I?
Try stopping
Try
you.
taking my mic on a row. Why am I showering in water that you've cleaned when there's 2.1 billion people in the world haven't got access to clean drinking water? Okay, I'll pass it on.
Stephanie said it was important to have a bath.
Shaun, my
Yep.
name is Mark Simpson.
Hi, Mark.
I'm 50 years of age and I have a confession to make. I don't know what a coagulant is.
Coagulant.
Oh, yeah,
Yeah.
tell me.
So basically, instead of the organic particles which are negatively charged, they're currently in the water in sort of suspension, and they are repelling each other. So they're kind of scattered throughout the whole volume of water. So this coagulant is positively charged. So this positive charge helps neutralize the negative charge, so that instead of them repelling each other, they start to come together. So it's kind of like your magnet principle, positive and negative. The two negative ends of the magnet will repel each other, but the positive and the negative will attract each other. So you're trying to upset the electrochemistry of the raw water to make it easier to bring the matter together to then remove it in the filter.
Thank you. Nice beard, by the way.
A bit like the pitch, needs a bit of work.
Shaun, I have a pressing question.
Okay.
What do we do with the sludge?
Sludge. Usually the sludge is taken away. It can be thickened. The water can be pressed, and the water can be taken out of it. So it's more like you talk about like a cake, a sludge cake, and ultimately it's taken to a landfill site, or I think in some instances they can, in a wastewater site, they can incinerate the sludge for energy. But normally in clean water, it's just landfill, unfortunately.
Opportunity to compost that or something like those?
I think that was general practice, and then the EU brought in a regulation where you couldn't use definitely wastewater sludge couldn't be used as a fertilizer. I'm not 100% sure about clean water sludge.
Thanks very much.
Good.
Any audience questions?
You mentioned the large volume of water that we require. In terms of energy consumption and the carbon footprint,
Yeah.
Would that be very large?
Yeah, water treatment plants are a massive consumer of energy. A lot of the work I do is down south, and our client is Irish Water, and Irish Water, I believe, are ESB's biggest client down there, the Energy Supply Board. So there is massive amounts of electricity demand. I know that just looked like a series of tanks, but there's mechanical mixers, there's air blowers, there's a massive amount of instrumentation, control panels. Yeah, it's.
How can we offset that then, in terms of water?
You mean in terms of using water to try and generate?
So how can we offset that large cost?
Well, I notice now some of the treatment works have started to install solar. So they're using solar panels to try and claw back some of the energy that they're using to run the works, but I think it's still very much in its infancy.
Yeah, I'll be down 1 wee sec. Yeah, I have another question about the sludge. What is it mainly made up of? Is it mainly organic?
Yeah, a massive amount will be organic, yeah.
So
There'll also be silts and sediments, there'll be some metals. It really depends on your raw water source. Whether it's, if you imagine your raw water has maybe travelled through a peat bog, there's a massive amount of organic content in the peat bog.
So it would be mainly organic, because just thinking, like, surely there's something that could be done with it, like, rather than sticking it in a landfill.
I see your point, yeah. But there's also a lot of chemicals that are used in the process. So you have these kind of residues and, from these sort of toxic metals, if you like. So I don't think it's just as straightforward as spreading it on fields and, using it as fertilizer, but it's probably something that should be looked into.
Okay, thank you.
Is there one at the front there?
Yeah, there's one here, yeah. Should narrow that down, really, shouldn't it? Just sort of.
Very possible. Are we just then reintroducing water that's going through this sludge back into the system again?
Yes.
Thereby reintroducing the chemicals that were expelled?
No, the sludge will be pressed, and the water then that is coming out of that will then make its way into a sewer. So it'll go through the whole wastewater treatment process, the same as if you flushed your toilet or your sink. So it doesn't go straight back in. It is treated before it's released back into a water course.
I understand that, but I'm just thinking that the water that's coming in from all sources, some of it's coming back through that sludge again.
Yeah, it's ultimately it's a loop.
Looks like that's an area that maybe we need to get the engineers looking at as well as the scientists.
Yeah.
More research, another PhD.
Anyone else, folks? All good, let's give it up for Shaun Reynolds one more time. Lovely stuff.